In the last unit of general concepts of food analysis and testing, we have already discussed about the overview of basic or the classical methods of food analysis. Now, today we are going to explain about principles of quality assurance and quality control with reference to the food analysis and testing. Now, we will discuss about the principles of quality assurance and quality control with reference to the food analysis and testing. Next, coming to the quality and safety of foods. Food quality control is the mandatory regulatory activity of enforcement of national, international and the local authorities to provide consumer protection and ensure that all foods during the production, handling, storage, processing and distributions are safe, wholesome and fit for the human consumption. At the same time, it must conform to safety, fulfill quality requirements and are honestly and accurately labeled as per the standards and specifications prescribed in the food law. Mainly, this food quality control is important for the consumer protection and it should be useful for the human consumption, and it should follow the standards and specifications required in the food law. Consumer movement across the globe has also increased in recent past, and as a result of export or import of the food products has become more vulnerable in compiling safety requirements of the consumer. The challenges listed are the key issues faced by the food control authorities, that is government or the regulatory bodies, which are responsible for ensuring food safety and quality. These authorities include international organizations like the WHO, that is World Health Organization, and FAO, that is Food and Agricultural Organization, as well as the local or the national regulatory agencies such as the FSSAI, that is Food Safety and the Standards Authority of India, or the FDA, that is Food and Drug Administration, which is in the US. Challenges for food control authorities include, that is increasing incidence of the foodborne illness and emergence of new foodborne hazards. What it means is there are more cases of illness caused by the contaminated food, often due to the new pathogens or the changes in the food handling practices. Next, coming to the rapid growth of advanced technologies in food production, processing and the marketing. Innovations in the food production, that is genetically modified food or the nanotechnology, require updated regulations and monitoring. Next one is the application of the science-based food control systems with a focus on consumer protection. Next one is the global increase in the food trade and the harmonization of the food safety and the quality standard. That is, food trade across the countries demands a common set of safety standards to ensure consistent quality globally. Changes in education standard awareness and lifestyles, including rapid urbanization and the growing consumer awareness of food safety and the quality issues, are increasing demand for the better information. The public seeks detailed information about the food they consume, such as the nutritional values, allergies and the origin of the food, where it is produced. They need every detail of the food product. The government authorities should address these challenges through proper regulations and monitoring. They must ensure compliance with safety and the quality regulations, adopt modern production techniques, responsibilities and maintain transparent practices. And the consumers should educate themselves about the food safety issues and make informed choices about what they eat. This diagram shows the food supply chain from the farm to the consumer, highlighting the key stages where quality control is crucial. First one is farm. This is the initial production stage where crops or livestock are cultivated. Next, coming to the farm storage. Storage at the farm before transportation to maintain freshness and the quality. Transportation. Moving raw material from the farms to the processing or packaging facilities. Processing set. An area where preliminary processing occurs before further storage or packing occurs. Sorting and packaging. Sorting products for quality and packing them for storage or shipping. Storage. Temporary holding to maintain the quality before distribution. Transportation and shipping. Distribution to markets, possibly involving multiple transport modes. Processing. Additional steps that may involve cleaning, cutting or further processing for final products. Coming to the market, products are displayed for purchase by consumers. Consumer, the final stage where consumers purchases and consume the product. Each step is essential for the quality control to ensure food safety and the freshness. This diagram shows the pathway of the contamination and cross-contamination in food production and processing environment. And the flow chart highlights how pathogens and contaminants can move through the various sources and affect human health. Plants and animals. Plants can be contaminated through the soil or water they are grown in. Animals may become contaminated by consuming infected feed or through exposing to contaminated environment. Feed. Contaminated feed can directly affect animals, which then produce contaminated meat, milk and eggs. Whereas the soil and water acts as a mediums that can spread contamination to plants and animals. These contaminants can stem from the sources like a feces, that is sewage, and other environmental factors. These feces and the sewage matter can introduce harmful pathogens to water and soil, which may then contaminate plants and animals and indirectly affect the humans. Insects, birds and aerosols. These can serve as vectors that transport contaminants between the various parts of the system, spreading them to plants, animals and directly to the food products. Vegetables. These can become contaminated through soil, water and cross contamination and environmental exposures, leading to the possible infection when consumed by humans. Meat, milk and eggs. These animal derived products can carry contaminants that originate from the feed, animals, living conditions or handling and the processing steps. Harvesting, handling and the process. During these stages, there are multiple opportunities for contamination due to the improper handling, cross contamination from the other products or exposure to pathogens in the environment. Humans. Finally, humans are affected by consuming contaminated food products. Additionally, humans can also contribute to the contamination during handling, processing or through poor sanitization practices. There are numerous pathways through which contamination can spread from the environment, animals and plants to the humans. What is quality? This is the outline for various definitions and the aspects of quality. An ISO 9000 definition. According to the International Organization for Standardization, quality is the degree to which a set of inherent characteristics, that is attributes like smell, taste, etc., which fulfills the requirements. This means that quality involves meeting specific standards or criteria established for a product or the service. Next, coming to the fitness for use. This focuses on the product's suitability for its intended purpose. A high quality product effectively performs the tasks it is designed for without unnecessary features or functions. Next, quality is excellence, that is better than a minimum standard. It suggests that true quality involves going beyond the basic expectations and delivering superior performance or the features. Next, coming to the conformance to requirements. It ensures that the product or the service consistency meets set criteria and the ability of the product or service to satisfy. The quality involves the ability of a product or service to meet the need. Quality have been defined as degree of excellence and include such as things such as taste, appearance and the nutritional content. It is the evaluation of the final product prior to its marketing based on the quality checks at the end of the production chain, aiming at assigning the final product to quality categories such as high quality or regular quality or low quality and non-marketable. Since at the end of the production chain, there is no way to correct production failures or upgrade the quality of the final product. The low quality products can only be sold at lower prices and non-marketable products has to be discarded. Quality control has only a limited potential to increase the quality and efficiency of a multi-step production procedure. ISO. This is the International Organization for Standardization. This is independent and non-governmental international organization. It brings global experts together to agree on the best way of doing things, from climate change and healthcare to quality management and artificial intelligence. Our mission is to make lives easier, safer and better for everyone and everywhere. We just see this is the logo ISO 9001 to 2015. It's a certified company. What is this numerical value? This numeric 9000 in ISO 9000 refers to the series number assigned to the set of international standards for quality management system. Specifically, ISO 9000 is a family of the quality management standards developed and published by the International Organization for Standardization, that is ISO. This 9000 series number was assigned to these quality management standards when they were first introduced in 1987. The number 9000 was chosen simply, just a random number, as a way to distinguish this set of quality standards from other ISO standard series, which uses different number schemes. Example, ISO 14000 for the environmental management standards. The 9000 does not signify any particular quality level or number of requirements. It is just the series number used to identify the specific set of quality management standards within the overall ISO standard framework. So, in summary, the numeric 9000 is the series designation, not a reflection of the specific content or the requirements of the ISO 9000 standards. It is simply a way to categorize and identify this particular group of quality management system standards published by the ISO. This image outlines the timeline and evolution of the ISO 9000 family of standards. These standards are related to quality management systems, that is QMS, and are designed to help organizations and ensures they meet customers and regulatory requirements while improving overall quality. This ISO 9000 describes the fundamentals and vocabulary for the quality management systems, and this ISO 9001, it specifies the requirements for a QMS to ensure the compliance and is the most widely used standard in the ISO 9000 family. And this ISO 9002 and ISO 9003 previously focused on specific aspects of quality, that is production lines, final inspections, but these are now obsolete. What do you mean by obsolete? Many of the earlier standards in the ISO 9000 series, such as ISO 9002, ISO 9003 and some parts of ISO 9004 are now obsolete. Over time, these standards were merged, simplified or replaced with the updates to ISO 9001. The most widely used and comprehensive standards for the quality management system is ISO 9001. And this ISO 9002 and ISO 9003, they were initially used for specific scenario like quality in production lines. ISO 9002 is used in the quality production lines and ISO 9003 is used in the final inspection and testing initially. By the 2000 revision, their scope were merged into ISO 9001. Organizations now use ISO 9001 for a more holistic and process-based approach to the quality management. With the introduction of ISO 9000 to 2015, many of these principles were incorporated into ISO 9001 itself, making ISO 9000 less central. The focus shifted to make ISO 9001 a single universal standard that could be applied across industries, ensuring simplicity and better global adoption. So, they merged everything. This ISO 9004 provides guidelines for the long-term organizational success, now incorporated into ISO 9000 to 2015. This timeline also shows the important updates to the standards, that is 1987. This is the initial release of the ISO 9000 series. And 1994, it is a revision focused more on the quality assurance and inspection. And coming to the 2000, emphasis shifted towards the process management and the meeting scaleholder needs. 2008 update introduced ISO 9000 to 2009, focused on the sustainable success. And 2015 is a major revision aligned with the PDCA, Plan, Do, Check, Act. It is a cycle for the system-wide management. Quality control. Quality control involves operational techniques and the activities that are used to ensure the product compliance to the specifications. What do you mean by this compliance? It means following the rules or meeting the requirements set by the specific standard laws or the regulations. For example, if a company is ISO 9000 compliant, it means they follow all the rules and guidelines of the ISO 9001 standards for quality management system. It's just like doing a homework according to the teacher's instruction to get approval. What is the goal of QC? It improves final products by identifying the defects. It is concerned with the sampling, testing and performing in-process quality control tests during and after manufacturing. What are the functions of QC? Quality control. It performs inspections and performs in-process quality control tests for samples and perform testings of raw materials and perform testings for the final products before dispatch. What are the components of QC? That is sampling and quality control labs, batch inspections and maintaining of records. The basic goal of the quality control is to ensure the product, services or a process provided to meet the specific requirements and are dependable and satisfactory. Essentially, quality control involves the examination of the product, service or process for certain minimal levels of the quality. The goal of the quality control team is to identify products or services that do not meet a company's specified standards of quality. If a problem is identified, the job of the quality control team or the professional may involve stopping production temporarily. Depending on the particular service or the product as well as the type of the problem identified, production or implementation may not cease entirely. Quality control can cover not just the product, services or the processes but also the people. Employees are an important part of any company. If a company has employees that do not have the adequate skills or training, have trouble understanding directions or misinformed, quality may be severely diminished. What we need to understand here is, if any problem occurs, they stop the production temporarily. If any problem identified, they will not cease entirely. Some attributes may need to be tested using the equipment to avoid argument over interpretation. This shows a diagram of penetrometer, a device used to measure the hardness of the food items, example tomatoes. The penetrometer has a weight that applies force to a cone which then presses into the food sample. The scale on the device measures how far the cone penetrates, indicating the sample's hardness. By using a penetrometer, food testers can quantify terms like hard or soft, avoiding subjective interpretation. This objective measurement is essential for the quality control, especially in processing, where the texture of the food can affect their handling and the final quality. The color and hardness are crucial for determining a product's condition after storage and the transportation. Control points. In every food process, there are particular stages which affect the quality of the final product. Example, the amount of heating given to the pasteurized juices after the color, flavor and the storage life, or in sauces, the amount and the type of grinding affects the texture of the meat. These stages are identified as the control points and the quality control checks are made at these points to control the process. Manufacturers therefore need to identify the control points in their process using the outside technical assistance if necessary and set up a specification for the operators to use. For example, in jam making, the amount of pectin, fruits and the sugar should be carefully controlled, and weighing of ingredients is a control point. Weights of each ingredient specified and each carefully weighed out. Likewise, the acidity of the jam, the sugar content after boiling and the temperature of filling are each control points. The mix should be checked for the correct acidity. The sugar content checked during boiling using a thermometer or the refractometer and the temperature checked before boiling using a thermometer. Checks are the control points, can therefore be used to control the process and to ensure that each batch of product has the similar quality. Quality attributes that are hidden and sensory. Harmful substances that are haplotoxins in the groundnuts and the microbials that are number of bacteria in the food which we can't see, and the nutritional value, that is vitamin content of the food, and additives are the artificial flavors and the thickeners, etc. And coming to the color, we can see it, that is ripeness of the fruit, size and shape, size of the chopped food, particle size of the flour, and thickness or texture, juice consistency and toughness of meat. Taste, saltiness, sweetness, sourness or bitterness, and the flavor is the characteristic flavor of the tomato. The basic tools of the quality control are the ingredient specifications, approved supplier list, product formulas and product standards that are specifications and manufacture procedures, and critical control point identifications or sampling program, and In-process analysis, records and reporting, packaging specifications, label specifications, cleaning and sanitization program, good manufacturing practices, requirements and recall programs, and warehousing, shipping and the receiving program, and the laboratory analysis. And commitment, awareness, teamwork, communication plus the quality control gives us the safe, wholesome and the consistent food products. This quality assurance, which is the part of the quality system, defining it as a planned and the systematic activities that is designed to ensure that the product or the service meets quality requirements. This QA is a structured approach that elevates the performance and service quality of the products against set standards, giving confidence that the consumer's expectations will be met. This diagram shows the relationship between the quality system, quality assurance and the quality control. The outermost layer represents the quality system, which covers all the aspects of the management quality. Inside it is the quality assurance, which focuses on processes to ensure quality standards are met. The innermost is the quality control, which involves specific testings and inspections activities to detect and correct the defects in the products. This layered structure demonstrates how quality control is a part of the broader quality assurance activities, which are themselves part of the overall quality system. Quality assurance. It focused on building the quality in the products through planned and systematic activities like validation, process and environmental control and documentation. Goal of QA improves the development process so that defects don't arise. Thus, it's a sum total of all the organized arrangements made within the object of ensuring the production of quality product. ISO 9000 defines quality assurance as part of the quality management focused on providing confidence that the quality requirements will be fulfilled. Quality assurance. It defines as a part of the quality management focuses on providing confidence that the quality requirements will be fulfilled. The confidence provided by the quality assurance is twofold. One is internally to management and externally to the customers, government agencies, regulators, certifiers and the third parties. An alternative definition is all the planned and the systematic activities implemented within the system that can be demonstrated to provide confidence that a product or the service will fulfill requirements for the quality. Quality control. It is also part of the quality management focusing on fulfilling the quality requirements. Quality assurance relates to how a process is performed or how a product is made, whereas quality control is more the inspection aspect of the quality management. An alternative definition is the operational techniques and the activities used to fulfill requirement for quality. Some more differences between the quality control and the quality assurance. This is the product oriented, this is the process oriented. We have already discussed this. And quality control is the reactive approach and the quality assurance is the proactive approach. What do you mean by reactive approach? Responding to the problems or events after they occur. It focuses on solving issues as they arise. This proactive approach is addressing the problems before they happen. It focuses on prevention and preparation. For example, if we want to say about the reactive approach is fixing a machine only after it breaks down. For this, regularly maintaining machines to prevent breakdown. And quality control is the corrective action, it is a preventive action. And it focuses on testing for quality, building in quality, detects defects, prevents defects. Meant for implementing the process developed by a team, meant for developing and organizing the best quality process. Make sure that the results of what you have done are what you have expected. Make sure that you are doing the right thing the right way. This shows the interrelationship between the quality management QM, quality assurance QA and good manufacturing practices GMP, quality control QC and the production in a layer model. Quality management, it is the outermost layer representing the organization's overall policy and approach towards the quality. It covers overall all activities. Coming to the quality assurance, which comes next to the quality management, focuses on ensuring that the final product meets required quality standards. Coming to this GMP, good manufacturing practice is a part of the QA, providing specific guidelines to build quality into the product during manufacturing. Quality control involves testing and inspection to verify products' quality at different stages. Next, coming to the production, it is the innermost layer where the actual manufacturing process happens, including in-process checks and self-inspections to maintain quality throughout the production. This shows that each layer supports the next, forming a comprehensive quality system in manufacturing. QC, it's a part of GMP that focuses on testing of materials, compounds and products in accordance with standards. Production department is the center of the quality management system. The quality of the production process is monitored by self-inspections, release controls and in-process controls. Self-inspections is program designed to detect any shortcomings in the implementations of the GMP to recommend necessary corrective actions. Release controls. These are the tests performed on the products that are to be released and distributed to the commercial marketplace. In-process control refers to the checks performed during an activity in order to monitor and if necessary to adjust the process and to ensure that the intermediate or finished products conforms to its specifications. Food safety. 4 steps to food safety, that is clean, separate, cook and chill. Food safety provides an assurance that the food will not cause harm to the consumer when it is prepared and or eaten according to its intended use. Safety is a component of quality. Safety differs from many other quality attributes since it is the quality attribute that is different to observe. A product can appear to be high quality, well colored, appetized, flavorful, etc. and yet it is unsafe because it is contaminated with undetected pathogenic organisms, toxic chemicals or the physical hazards. On the other hand, products that seems to lack many of the visible quality attributes can also be safe. Salmonella contagion of a peanut butter in the US, melamine contamination of milk in China and high pesticide content of the aerated drinks manufactured in India has significantly enhanced the concern for the food safety and its impact on health marketing and the foreign trade. Protecting consumer health from the foodborne hazards has become a compelling duty for policymakers across the globe. Specific concerns about food hazards have usually focused on, that is microbiological hazards. Next is the xenobiotic residues including synthetic, that is man-made pesticides, drugs, antibiotics and the plastics. What do you mean by the xenobiotic residues? These are the trace amounts of the foreign substances such as chemicals or the compounds found in the living organisms or the environment. These substances are not naturally produced or expected to be present. Next is the misuse of food additives and the chemical contaminants including the biological toxins, adulteration, artificial foods and genetically modified organisms, allergens, veterinary drug residues, radionuclides and the growth promoting hormones which are used in the preparation of the animal products. This shows the food supply chain and the associated responsibilities of the stakeholders for food safety and the quality. Supply chain stages. First is the agricultural production, begins from farm with the production of agricultural goods. Next is the sales of commodities or the raw materials. It involves the sale of the raw materials on local, national and the international levels. Next is the manufacturing and packaging. Food products are manufactured and packaged. Next is the sale of food products. Food products are then sold through import, wholesale or retail channels. Consumers. Ends from fork, indicating that the final consumer receives the product. Stakeholders' responsibilities for the food safety and the quality. Good agricultural practices ensure safe and sustainable farming practices, and the good distribution practices maintains quality during the distribution of food products. Good manufacturing practices focuses on manufacturing standards to ensure the food safety and the quality. And this good hygiene practices, that is HACCP, hazard analysis and the critical control point, which ensures the hygiene and the safety protocols throughout the production and the distribution process. This supply chain and the quality assurance model aims to ensure that food is safe from production to consumption. Quality control in food processing business. Quality control is not an optional. It is an essential component of any food processing business. The purpose is to protect the consumers from the dangers, example contaminated foods. It is used to protect the business from cheating by the suppliers, damage to the equipment, example stones in the raw materials, and the false accusations by middleman customers or the suppliers. To be sure that the food laws operating in a country are complied with. Quality control need not to be time consuming or expensive, and the results of the quality control tests should help save money in the long run. In general, the quality control procedures used should be as simple as possible and only give the required amount of the information. That is, too little information means the test has not done its job. Too much information and management discussions may be delayed or confused. And the quality control is used to predict and control the quality of the processed foods. It is no use producing a food, testing it to find the quality, and then trying it to find the buyer for the particular batch of food. The quality control, it is used to predict the quality of the processed food and then control the process so that the expected quality is achieved for every batch. This means that the quality specifications must be written, agreed with the suppliers or sellers, and control points must be identified in this process. Quality specifications. The quality of the foods or ingredients can be measured in different ways, but one popular method is to describe quality attributes. That is, a specification can then be written or agreed with the suppliers or sellers, which listed the quality attributes that are required in a food. For example, quality specifications for tomato intended for the processing into a paste or leather is shown in table. Quality attributes for tomato. Quality attributes for tomato. Color, which is orange or red, it is acceptable, and more than 10% green, it is rejected. Shape and size is anything is acceptable. Damage. Splitting less than 5% is accepted and more than 5% is rejected. Insects less than 5% is acceptable and more than 5% is rejected. Molds. If no molds are present, it is acceptable. Any evidence of mold is present, it is rejected. Hardness. Soft to over soft is accepted and more than 10% hard, it is rejected. A number of points arise from such a specifications. The representative sample of the food must be tested to make sure that the whole batch meets the specifications. For small batches, it may be possible to examine every item. The size of the sample needed for the testing can be calculated, but this is fairly complex and usually unnecessary for a small scale business. The percentage of substandard items which cause a batch to fail the test can be increased or decreased depending on how reliable the supplier is or how important the particular attribute is to the seller or the manufacturer.
What are the responsibilities of QA? The QA department is responsible for ensuring that the quality policies adopted by the company are followed. It ensures the adherence to the quality policies and GMP standards. It helps to identify and prepare the necessary SOPs related to the control of quality. What do you mean by SOPs? That is the standard operation procedures for the quality control. It must determine that the product meets all the applicable specifications and that it was manufactured according to the internal standards of GMP. And QA also holds responsibility for the quality monitoring and audit function. It monitors quality and conducts audits. Audits means its examination or the verification. And QA functions to assess operations continually and to advise and guide them towards full compliance with all applicable internal and the external regulations. And it is responsible for the day-to-day control of the quality within the company. This department is responsible for the analytical testing of the incoming raw materials and inspections of the packaging components including labeling. They conduct in-process testings when required and perform environmental monitoring and inspect operations for compliance. And they also conduct the required tests on finished dosage form. Overall, it checks the quality control activities like testing raw materials, packaging components, in-process testing, environmental monitoring, and it also do the finished product testing. Control of quality variations. First one is raw material control. Good raw material specifications must be written in precise terminology, must be complete, must provide specific details of the test methods, type of instruments they use, and the manner of sampling must be properly identified. Specifications and sampling methods must be predefined, and each raw material is sampled according to the standard sampling procedures and is sent to the quality control laboratory for testing according to the written procedures. If acceptable, it is moved to release storage area after being properly stickered to indicate the item number, material name, lot number, and release date, reassay date, and sign of the quality inspector. Reassay means it's the process of retesting of a material or the product to confirm the quality with specific standards after a certain period. And QA personnel should keep preservation samples of active raw material that consists of at least twice the necessary quantity to perform all the tests required to determine whether the material meets the established specifications. Approved material should be rotated so that the old stock is used first, and the raw materials may be classified into two groups, active or therapeutic and inactive or inert. Here, samplings follow standard procedures before testing in QC labs, and approved materials are stored systematically for use, and QA ensures preservation samples are retained for future testing. This active or the therapeutic raw materials are the vitamins, enzymes, and the probiotics. They treat, prevent, or manage a condition, provides a direct therapeutic benefit. Whereas in indirect or the inert raw materials, they are the preservatives, flavoring agents, and the emulsifiers. They enhance the product delivery. They improve the shelf life, appearance, and the usability. Quality is everyone's responsibility.
Now I'll explain you about the modern analytical techniques in mass spectrometry and the molecular techniques in food analysis and testing. The demand for the quality and the safety in the food products have made analytical techniques critical in the food analysis. Among these, mass spectrometry and the molecular techniques have emerged as vital tools to ensure food authenticity, detect contaminants, and assess nutritional value. This explores these techniques focusing on their principles, applications, and importance in the food industry. Now coming to the mass spectrometry in food analysis. It's a powerful analytical techniques that identify and quantifies compounds by measuring the mass to charge ratio of ionized molecules. It is widely used due to its precision, sensitivity, and ability to analyze the complex mixtures. Mass to charge ratio is to describe the charged particles such as ions. It is the ratio of the mass of the particle to its charge. For example, if an ion has a mass of 12 AMU and a charge of +2, means 2 electrons, its m by q, that is mass to charge ratio is equals to 12 AMU by 2 electrons. Then we get 6 AMU by electrons. This is the mass to charge ratio. Now let us discuss about the components of the mass spectrometer and its applications in food analysis. First, coming to the inlet. This is the entry point where the sample is introduced into the mass spectrometer. Whatever the food sample we wanted to test, we need to introduce here. The sample can be solid, liquid, or gas form depending on the type of analysis. In which method the sample will be introduced? There are different types, that is direct insertion. Direct insertion means a solid or liquid sample is inserted directly into the ionization source. And the next method is the gas chromatography interface. It uses the volatile compounds that are first separated in the gas chromatograph. Next method is the liquid chromatography interface, used for the liquid samples or the mixtures that are separated via the liquid chromatography. Now coming to the source, that is ionization. The ionization source converts molecules into gas phase ions, which are necessary for mass analysis. There are different types of ionization methods used here. One is electron ionization, means a high energy electron beam bombarded the sample, removing an electron to produce the positive ions. Next method used here is electrospray ionization, that is ESI. A liquid sample is passed through a fine capillary, creating charged droplets that evaporate, leaving gas phase ions. Coming to the analyzer. The analyzer sorts ions based on their mass to charge ratio, that is m by z. And the types of analyzers used are quadrupole. It uses the oscillating electrical fields to selectively transmit ions with specific mass to charge ratio. Common in routine analysis due to its accuracy and speed. Next type of analyzer used here is time of flight, TOF. Measures the time ions takes to travel a fixed distance. The lighter ions reach the detector faster, providing high resolution results. Next type of analyzer is magnetic sector. Uses a magnetic field to bend ions trajectories. Ions with different m by z values follow different paths. Next analyzer is ion trap. Traps ions using the electrical fields and sequentially ejects them for detection. It is useful for tandem mass spectrometry. Next one is the ion detector. It converts the incoming ion signals into an electrical signals that can be measured. And the types of detectors used are the electron multiplier, which amplifies ion signal by causing secondary electron emissions. Faraday's cup measures ion current directly, less sensitive but robust. And next ion detector is microchannel plate. This is highly sensitive, used in TOF systems. TOF system means time of flight analyzer systems. Next is the data system, which collects and processes the electrical signals from the detector, produces a mass spectrum, which is a graph of ion intensity versus m by z. Its function is to determine the molecular weight and structural information of compounds and provides quantitative data, which is the concentration of ions, and enables quantitative analysis, that is identifying the unknown compounds. Next, coming to the applications in food analysis. Detection of contaminants and adulterants. This mass spectrometry detects pesticide residues, heavy metals and the mycotoxins in food. Example, liquid chromatography MS. Liquid chromatography mass spectrometry is used to identify the pesticide residues in the fruits and vegetables. Next one is the authentication of the food products. It ensures the geographical origin and authenticity of the products like honey, olive oil and the wine. Next one is the analysis of nutritional content. It quantifies vitamins, amino acids and the fatty acids. Next one, mass spectroscopy is used in the detection of the food frauds. It identifies the mislabeling or the substitution of the ingredients. For example, identifying the horse meat in processed beef using the mass spectrometry. Coming to the advantages of mass spectrometry, it is highly sensitive and accuracy and able to analyze small quantities of the samples and versatility in detecting a wide range of compounds. Coming to the limitations, it is highly cost and requires skilled operators for data interpretation. Coming to the molecular techniques in food analysis, it is essential for detecting the foodborne pathogens, identifying the genetically modified organisms and verifying the food authenticity. And these methods rely on the analysis of the DNA, RNA or proteins. Prominent molecular techniques used are polymerase chain reaction, that is PCR, which amplifies specific DNA sequence to detect pathogens or the genetically modified organisms. Example, identifying Salmonella or the E. coli in the raw meat. Next is the quantitative PCR. It provides quantitative data on the concentration of the DNA targets. It is useful for detecting allergens in the food products. I have already explained this all in the before classes. Please check it out once. Next, coming to the next generation sequencing. It offers comprehensive genomic analysis and applications are microbiome analysis in fermented foods and detecting unknown pathogens. Enzyme linked immunosorbent assay ELISA. It detects proteins or allergens using antigen antibody interactions. commonly used to detect gluten or the peanut allergens. Biosensors. It detects specific molecules like toxins or pathogens. An example is rapid detection of aflatoxins in the cereals. Coming to the applications of molecular techniques, food safety, detection of pathogens such as Listeria and Campylobacter and the noroviruses. And it's also applicable in food authenticity, identification of animal or plant species in the processed foods. GMO analysis, differentiating genetically modified crops from the non-genetically modified counterparts. And shelf-life assessment, monitoring the microbial spoilage over time. Coming to the advantages of the molecular techniques. It's highly specific and sensitive, rapid and reliable results, and minimum sample preparation is used for the molecular techniques. Coming to the challenges, high initial investment is needed and a complexity in interpreting results for mixed food matrices. And the applications of mass spectrometry and the molecular techniques has revolutionized food analysis and testing. Their ability to produce accurate, sensitive, and the rapid results ensures food safety, authenticity, and nutritional quality. However, the challenges of the cost and the complexity must be addressed to make these technologies more accessible. With continued advancements, these techniques will remain pivotal in meeting global food safety standards and the consumers' expectations. If you like the video, please do like, share, and subscribe.